Login acceptance.
Hello everyone, hello Devoxx Poland. Really nice to see you here. Hope you enjoyed the lunch break. Now you have full energy for yet another session. So today we're gonna talk about design for GitOps. So how your applications may be suited or fit into the GitOps paradigm I'll talk about. I assume many of you might not have heard about GitOps yet. But probably most of you have heard about DevOps. And I've heard that DevOps to GitOps is like Java to JavaScript. Same, but totally different. And today, I really want to share with you what we have learned at Dynatrace, where I work now, what we have learned from everything as a code at scale, so the massive scale of thousands of users, hundreds of developers, tens of thousands of services. So a little bit at the start, a little housekeeping. Hate or love me, add our Devoxx app, submit feedback there. I really appreciate this. And prepare your questions so you can ask this at the end of the session. So I'll start my talk with one of the greatest and most recognized quotes in our IT world, a quote from Satya Nadella, a CEO of Microsoft. And he told that every company is a software company because every company is driven by demands for better, more connected digital experiences. And that's why we all talk about more and more on every conference about DevOps and continuous delivery because we want to deploy and deliver faster new digital services for better digital experiences for our users. And who else than Jim Kim I would ask about what the DevOps is. Jim Kim was a founder, a pioneer of DevOps culture. And he told many things about DevOps, but this quote I love the most. And he told to take lean principles and apply them to the technology value streams we have. And then we end up with emergent patterns that allow organizations to do dozens, hundreds, or even hundreds of thousands of deployments per day, like Facebook, for instance. And this is, of course, important, the pace, but we need to preserve world-class reliability, security, and stability, obviously. And to understand what the DevOps is, one of the simplest ways is to present the CALMS model. So John Willis and Damon Edwards in 2010 coined the term CAMS, actually, which was then later expanded to CALMS by Jess Hamble. And this is an acronym and stands for Culture, Automation, Lean, Measurement, and Sharing. And to understand the model, at the base is culture, is people, because this is what the DevOps is. That's the essential thing. Communication, systems thinking, as Jessica Kerr told us yesterday at the main stage. Clean interactions between teams, adopting agile practices, bringing everyone to the same table to work on the same thing, same goal. And then there are 4 pillars, essential pillars of DevOps. Automation, of course, to establish a repetitive automated process to deliver quickly, same way from dev to prod. Lean, of course, to reduce waste and to get rid of low-value items and processes and activities. Measurement, finally, to establish KPIs and adopt observability. Measure your process to remove bottlenecks. And then finally, sharing code between teams, sharing common tools, common processes, common learnings from incidents, as Kasia said on the previous session. And that finally enables us to start and close it with DevOps transformation of our companies, organizations, teams. But that's practice. And I also digged more into this and went for data, because data is what matters. And for this, I have analyzed this year's State of DevOps report, very interesting one, this year presented by Puppet. And they did something very, very interesting. They wanted to understand how actually organizations all over the world adopted DevOps practices, where they are on that journey. And for this, they have created a model to measure their position and put on an evolutionary scale. And to create the evolutionary scale, they scored responses based on how frequently respondents apply each practice of pillars I have presented on the previous slide. So the score was at 1 point if you never adopt a practice, 3 when sometimes, and 5 when always. And based on this score, report makers grouped those and built a composite score, so each company gets 1 score, and they have categorized them on 3 groups: low, medium, and high. Low means that organizations are not employing any practices, mids that employ some of the practices, and high when adopt all of the practices always. And to get your feeling what this means and how it works, let's do a simple test now. I will compare our results here in that room with the score of the overall world. So we'll see where we are as a Polish and DevOps participants. So let's base on 4 key software performance metrics, which is deployment frequency, meaning how often you deploy to production. Lead time for changes, so how long it takes from the commit of your change to be present on production system. MTTR, so mean time to recover, so how long it takes to recover your system from a failure. And 4th metric, change failure rate. So simply, how often it happens when a failure happens on your production after a change. Right? So please raise a hand, look to your friends all over the room and see where you are, where you classify, where you would fit the most into either group of low, group of mid, or group of high. And then let's compare the results from the report. So who think their team, their organization, fits into the low group? Raise a hand, please. Don't be shy. Okay, a couple. Who thinks will fall into the mid group then? Okay, I see majority. Sorry. And who thinks is in the high group, high evolved DevOps? Also, few people. Okay, good. So let's compare it then to the results of the world. And what it occurs that this year, 18% of organizations all over the world fall into the high group, 78% of mid, and 4% in the low, which more or less is exactly what we tested or practice now. Good. So then, question of course rises up in our heads: how to advance to become better, how to deploy faster, how to deploy more convenient, with more trust that it won't fail. And some of you probably may say, well, automate more. Automation was one of the pillars of the CAMS model. But DevOps is not just automation. It's key, but it's not just automation. Being good at automation doesn't make you good at DevOps. Of course, 90% of those highly evolved organizations report they have automated most of their repetitive tasks. That's great. Almost all of them agree that automation really improves the quality of their work. And, maybe surprisingly, majority that are stuck in the mid and can't go even higher also report high levels of automation. So what to do more? How to become better? There's something else. Maybe cloud. DevOps is not the cloud. Of course, it's important, but almost everyone now uses the cloud. But most of you use it poorly. Highly evolved DevOps companies use it well, so we can learn from them. That's why organizations should not expect to become highly evolved, best at DevOps culture, because they just use the cloud and automation. While 2 in 3 respondents report using public cloud, only 1 in 4 use cloud to its full potential. Majority of mids, those stuck in the mid, the largest group, report that use the public cloud, but only 20% of them use its full potential. So what blocks them at most common? It occurs that team identities and clear interaction paradigms matter, not the automation, not the cloud. Cultural brokers are keeping mid-evolution firms stuck in the middle, and they're unable to go further. And third, platform teams, internal platform teams, are key to success at scale. And whereas we could talk about all those three, these are 3 big topics. Now, I want to focus on the third topic of platform teams and scale, and how to build it efficiently. And I've also checked how can we become better at using cloud, how to leverage its full potential. And there's National Institute of Standards and Technology, cloud capability metrics, actually 5 of them. Broad network access, resource pooling, rapid elasticity, measured service, and finally on-demand self-service. That are actually based off internal platforms. And what it occurs? It occurs that indeed, majority of those high evolved companies agree with all 5 NIST capability metrics. And only 20% of those mid use this. So these are really top 5 things you can focus on and improve on this and work on this. So to sum up the report then, most highly evolved organizations, if you pretend to be that highly evolved organization in DevOps models, they are adopting a platform model to enable self-service for developers, and that curates developer experience, that curates our experience, that enables us to move faster and faster and better. And sometimes, to understand the presence, we need to understand the past. So let's take a step back and see how it was in the past. And in a not so distant past, hope you are not still there, there was an application owner. There was just a few teams that worked on a monolithic application that probably worked on few virtual machines. And a typical question, a request, sometimes a ticket. Hey, can you enable me observability? Hey, can you enable me notifications? Hey, can you build me a dashboard or send additional metrics to the operations team? An operations team, of course, with a great pleasure, fulfilled their request. Hey, sure, no problem. Let's take off this right away. But now, world has changed and moves rapidly, and we no longer have one application owner, or maybe few. But we have microservices teams, tens of them, dozens, maybe even hundreds, working concurrently in the same thing. And all of them will have same problems, same needs. Hey, build me Slack notifications. I need availability tests, SLOs, logs, whatever, and I need it right now. It's very urgent. And that causes a headache of operations teams. Traditional operation teams are not feasible anymore at that scale. And the only solution is self-service. One of the simplest and quickest implementations of self-service is actually GitOps. What it is? So CloudBees defined it as a paradigm, a set of practices that empowers developers to perform tasks which typically fall under purview of IT operations. It requires us to describe and observe systems with declarative specifications. For instance, in YAML or in JSON files or in custom structure. And that eventually form the basis of continuous everything. What are the key points of GitOps then? Some of you might probably have heard about GitOps when working with Kubernetes, because originally GitOps was used to describe the cluster state, to manage the cluster state, and to deliver applications on Kubernetes. But you can apply this actually to different things, like to permissions, like to infrastructure, for instance, to configuration. The only thing is that Git will be the single source of truth. Of course, for free, then, using Git will have the configuration or the state automatically versioned by Git and audited. And the changes to the config base will be applied to the target environment, to the target application, to the target service. And it's very natural for us because probably many of us work with Git already. It's already the center and should be the center of delivery pipelines. So we already should be familiar with the process, with pull requests, merges, and approvals. The other connected term with GitOps, with DevOps, is toil. And we need to limit the toil. What the toil is? So the toil is defined as work tied to running a production service that tends to be manual, repetitive, automatable. It's the tactical work. And what is important, it scales linearly as the service grows. If you need to do double of maintenance work when your service doubles its size, it's something bad. There is a place to automate that, to get rid of this. And it's also very tied to lean. And of course, now we have driven to the design for GitOps when we finally understand what the GitOps is. Now I'll share my experience, our team's experiences when working on our application and fit that into the GitOps paradigm. And what we have learned is first, RESTful API, we need to go apply RESTful API principles, like CRUD and idempotence. So you need to expose, first of all, of course, all your resources, configurations over the REST API. And you need to allow to create that configuration resource or permission resource, infrastructure resource, retrieve it, update, and delete. That's an acronym, CRUD. We need to comply with idempotence. So when you send multiple times the same request to update a resource using a put method, for instance, it won't be changed and multiple times, so the state will be persisted. It's also good to follow the RESTful naming conventions. For instance, same way of how you retrieve resources, or when you return a list of resources of a given type, I don't know, infrastructure, permissions, configurations, whatever, it always fall down into the list named results or list or whatever. But to be consistent there, use naming conventions, agree with your teams on the naming conventions. And for me, most important, completeness of API. That was one of our struggles. We wanted to enable other teams to use REST APIs of given services, but they were unable to actually do this completely because REST API was not complete. They could automate certain things, but then it had to be followed by some manual operations. That's very, very bad. And here I want to highlight and stress that REST API should be treated equally to GUI, to graphical user interfaces. This is also a user interface. And no matter if with that user interface your users will use, or there will be other teams or other services, we need to treat it equally. It has to be complete. What my teams frequently ask me, hey, do we want this for this operation REST API? And I ask them, can we do this in UI? Yeah, then of course. If you can do something in UI, you should be able to do it in REST API. How easy is to filter for a term in UI? Just type it in the search box usually. And same thing should be applied to REST API. If I want to retrieve a given list of objects by a filter, it should be enabled by a filtering mechanism by passing a request attribute, for instance. It should be as easy as that. So always treat REST APIs as UIs. That's the same thing and should go hand in hand in line. Fourth thing, open and up-to-date and transparent documentation. In Java, you can easily adopt OpenAPI v3 library and annotate your REST endpoints very easily, describe every field, every method, every endpoint, and then generate automatically a Swagger UI with a complete, great documentation. I'll show later how it works in our example in Dynatrace. But it's really a big, big enabler for other. So you are not hit by other teams. Hey, how this endpoint works, or what to pass in that payload, or where is your documentation of REST API? Hey, your documentation, your wiki is not up to date. No, documentation should be in code. Together in code, also go hand in hand. And OpenAPI v3 and Swagger helps. Another thing connected to REST APIs, rate limiting and throttling. Also prepare your application to throttle if there are too many requests. You simply can't allow to kill your service by others who are testing this or made a mistake and called too many times and overload your services. Another thing, what we have learned, granular authentication tokens, right? So usually to call a REST API, you need to be authenticated. Usually you use some tokens like auth tokens or auth0, whatever. But usually I have seen that companies are using just one. Oh, that's one token and allows you to do everything. What if that leaks out? You are then in big trouble. Granularize that. So you have a token responsible for, I know, creating one set of resources, like for instance, I know, infrastructure services, and then the other token that will allow you to maybe just read what's the current state, or the other token scope that allows you to manipulate the other resources. Granularity then is important because it allows you to more control what permissions you give to certain services or certain users. Either read or read and write or access that endpoint or this endpoint. That's really important. Finally, Git, right? Git enables us, gives us for free auditing because of the history. We know who submits a change, who applies the change, who merges changes. Approve our workflow. So certain teams maybe are allowed, or a team leader may be allowed to approve those requests, and you don't need to nag other teams. Hey, can you merge this? Hey, can you review this? Think self-service. And then finally, webhooks integration. So you can be notified in your Slack, Microsoft Teams, whatever. And what also helps is open source for even enhanced collaboration. So either open source that to other teams inside your company, so others may contribute. So if they request something from your service, from your team, they don't wait endlessly when you'll have time to implement something, but you enable them to actually contribute, and that goes faster then. Or you can open source the whole world, if that's possible, and then you can count on the help of the whole world and evolve faster, be better, get feedback sooner and better. So how have we applied GitOps in our company? For you, I have 3 examples. Infrastructure as a code, permissions as code, and observability as code. So let's start with the first one. So for infrastructure as code, we have actually built a infrastructure provisioning platform. We call that Project Cloud Control. So we control the cloud with this. And we have all our infrastructure mainly deployed in AWS. We have thousands of virtual machines, different services, load balancers, application load balancers. And what we have done, first of all, we have built a service so each team member or members from other teams can just simply go to our service and click a single button, fill a simple form. Hey, I want a cluster, 3 instances deployed in Frankfurt region with load balancers, and that's it. And it automatically creates everything, provisions infrastructure, builds services, applies security groups, sets up networking, installs the application, and in a few minutes you have everything set up. And you can start testing, start collaborating, start building. That's a big enabler, because we no longer wait for the operation team. Hey, can you run me a cluster in AWS, set up everything, same time for every team. Self-service. Another thing, very important when you deal with the infrastructure, you need to control resources. So you need to query, for instance, a cloud API and see, hey, how many IPs you have already leveraged or consumed, and if you are close to the exceeding pool of this. So control your resources. So you also control the cost of this. And third tip, for instance, from AWS events. So control cloud provider service availability. They often have system failures, services failures. They want to rebuild a given infrastructure. You don't want to be surprised by this. So you can query their API and be notified beforehand. Hey, this virtual machine is going to be terminated or be recreated in 7 days or in 30 days if you don't do it yourself. Here, it's transparently showed for everyone, and you know simply about this. Right, so that's the whole. We see how many clusters were deployed, how they were built, what is happening, who is the owner of a given cluster, when it will be terminated, and so on and so forth. So that's one of the examples of our internal platforms that enables others. On Dynatrace, we work in 1,000 plus software engineers, and I can't imagine how we could work without this, without enabling others, with helping. Second example, permissions as code. And for this, we have developed Project UPM and Heimdall AWS. What we wanted to do, or what we wanted to improve on, we wanted to make the complex process of creating new resources in cloud easier, simply. Because it was, complicated. Subnets, security groups, infrastructure, services, deploying, installing. we wanted to have a single point of permissions and service users. Because we deal with multiple clouds, multiple accounts, and it will be just a waste of time if we jump from one account to another account to another account to see what users are here and there, what permissions they have. Maybe they leave the company. Maybe they want their permission to be elevated, and we need to check this and this and this and that. We want to have a single point of truth. That eases, right? And of course, we wanted to have permissions management via pull requests, right? So if you want to have your permissions elevated, for instance, for that sprint because you work on something more important, you just submit a pull request. Hey, I want to have my role extended or additionally role in that account or that cloud. You just create a pull request, and then the team approves this. Natural. So UPM is a user permission manager, and it allows us to assume a given role to access AWS account and services. Because we have a closed security politics. So we only allowed what we are allowed to do and nothing more. And that's really safe, because then you can't terminate someone else's instance by mistake just because you had too many permissions. Or you won't reconfigure a network by mistake on production. And then Heimdall AWS is a tool for us to simplify management of AWS resources and policies. Because it's not that trivial, it's not that one-liner in AWS, hey, I want that role. Sometimes you need to create a role, assign policies, configure policies. We have simplified that with our API. So, of course, we store configuration in Git, right? So with different categories or directories, we have defined roles, policies, configurations, user accounts defined in the JSON files. That teams modify this in order to submit a change via the pull request. And we have a simple UI for this, so everyone can self-service, go and see to what cloud accounts they have access to, what roles they have, and what's available for them in case they want to elevate their permissions. And what they do, they just click a button, assume a role. And that logs in them securely with elevated permissions to the console. So they do what they have to do, and then they log out and back to their normal permissions. I think it's interesting how it works, actually. So we have put at the beginning a bunch of JSON files to the configuration stored in Bitbucket. Right? And when someone wants to enable more roles, enable more users, they submit the JSON files, merge that to the master on the pull request, and then Jenkins' job fires Heimdall AWS service I told about, which generates CloudFormation templates, and that deploys to AWS CloudFormation service. And also we update our AWS QLDB, and that stores all the users and all the roles to serve on the UPM service, so User Permissions Manager. So you know where you have access, and you can assume the role. Quite simple, but powerful, and also enables others. And you can use the UPM to log in, as I told, but you can also download credentials to generate SSH client, or use AWS client, or use the SDK as well. And third example, my favorite, my beloved Dynatrace monitoring as a code, which is a tool set. And actually, underneath each service of ours, there was a similar story. Let me tell you what story is under that Dynatrace monitoring as code. So we have started with our R&D organization, because the need creates innovation. We had a need. We need to monitor a lot of Dynatrace environments consistently and automatically, because we couldn't bear that scale. There was too many things to do manually. So let's do the hackathon together. That'll be fun, and we'll do something useful. And it occurred that it was a success. We wanted, of course, to adopt that internally first, see if it helps our DevOps team, our teams to automate things. Indeed, it helped. And we understood that we need to share that all over the world to our customers, to all our users outside the organization, so they can also automate their configuration, their monitoring settings, because they had exactly same problems as we had. So we open source that and tell them, hey, this is open source. Maybe it's not perfect, but this is something you can get and improve if you want. And it's available at dturl.net/Monaco. If you want to see how it works, that's a Go project, a very simple. I strongly believe it's very simple to fork and adjust to your application, because it just executes REST APIs, dumps get methods, and allow to update simply. So Monaco, it was called. If you take Monaco, that's a project Monaco. And I wish we worked in Monaco. It's a beautiful city, but in fact, we live or we work in the other beautiful city of Gdańsk at the north of Poland. But still, the entry is Monaco. Of course, follows GitOps paradigm. It's a configuration of our application kept as code, version controlled, of course. We followed pull requests, approval workflows, all that I have said before. Then we have zero-touch configuration, because we don't touch the application anymore, but we interact with Git and change the state. So by this, we can automate application onboarding on a massive scale. So we have, for instance, one configuration set, one state, and we apply this same way, for instance, every hour to the test environment, or we want to apply this configuration change to all of hundreds of environments of our teams, customers, different stages. For instance, when we change an alerting policy, for instance, to be notified 24 hours instead of 12 hours, we don't need to click over hundreds of environments manually to set this, but we just modify files in Git and merge that, and that's Monaco does everything for us. So that applies also promotional flow, so we can promote configurations from dev to staging to production. We can synchronize configurations, as I told in the example. We can finally download the configuration that is currently present in our application to start, for instance, GitOps. And we can build fast packs. For instance, a given state of configuration that is suitable for onboarding of your application. So, for instance, typical dashboards or templates, or already there are free test accounts created, things like that. So how it works in the real life then? So let's imagine I'm a software developer, and I need a dashboard to visualize my service level objectives for my project. So I define in a JSON file what I would like to be. For instance, I would like that my dashboard is my application overview. It's time for 6 hours, and it's configured, blah, blah, blah. I define this. I put this together to my application structure, to my Git. So I put a directory, for instance, I know monitoring settings or Monaco, and then I define my JSON files. I run or extend my pipeline, for instance, in Jenkins, and apply another step, hey, apply me Monaco after you build your application. And then Monaco, when your application is built and deployed, it applies configuration based on the configuration files you stored. So it automates this, right? And we end up with the beautiful dashboard we wanted to have. That's how it works. And let's do the live demo then. Let me show you how the Monaco works. That will be a simple demo. But I think with this, you can easily get how it works, right? So that's an example of my Git repository. For this Git repository, I have a YAML file, and you don't see what I see, so let me move it. All right, and let's do that trick. And let's do that trick. Hope you see a little bit better. Right, so I have my YAML file, and this is my link to my environment of my service. Of course, it's secured by the token. And I have my directory of different configurations that I want to manage. One of the configurations, for instance, I want to modify is maintenance windows. And I have my JSON file for Devoxx lunch break, so a given state. And let's modify this because I want to have a change. For instance, let's schedule our lunch break, so I don't want to be alerted during the lunch. And our lunch was like, for instance, 12:30 till, let's say, 30:30. That was a simple example, so we don't fall into something more advanced. Whoops. Where's my cursor? Come on. All right. Oh, now I'm back. All right, so I commit my changes. And what has happened? When I committed change, the workflow has started, and for that example, I have used GitHub workflow. So GitHub Actions, here's my workflow change that currently builds. So it sets everything up, downloads Monaco, set permissions, deploy Monacos. So you can see the log. Everything worked fine. So you see, I don't lie. Let's go to Dynatrace. Here, you're welcome to jump to our booth to see what the Dynatrace is and how it works. Don't want to go into the details now, but we have a configuration settings of configuring maintenance windows. Right, so this is what I don't lie. There was a 2020 configured. Let's refresh this. So let's see if it was applied. Indeed, that is a new maintenance window I have configured using the GitOps approach. So I have modified the state in the Git, run automatically through the pipeline Monaco, and applied the configuration. So I don't need the access actually to the configuration, to the application, to modify its state. I'm authorized by the token I was given. So also one problem less. And the other example, actually, that I really love was from our customers. Because when they received the tool, because it was open source, they have started to think, hey, how can we use this? And the ecosystem they worked was Azure. And what they did, they have created a simple form using Azure Web Apps. They have built a form to request a given service. Then they have used Azure Logic App to process that form. They have created Azure DevOps pipeline that executes that Monaco, and Monaco executes that and configure Dynatrace. So flow, very automated from a simple form for a typical user that don't need to understand things. They just want to have, for instance, a dashboard. Right, so the initial configurations was stored in the Git repository. Onboarding new applications is very easy because there's already a template for a given settings that we wanted to persist and promote to different environments. Integrations were set automatically. Maintenance windows were configured by the policy of our organization. Microsoft Teams notifications were also used automatically and configured automatically, because that's what the team use every day. And they have created synthetic tests automatically using Monaco. And finally, they have configured the integration of monitoring Azure and AWS with Dynatrace. So they have combined every need that usually their team needs, no matter what the team is almost, in the Monaco. And they fill just a form, and it does the rest, Monaco. So if you want to learn more, visit GitHub, type Dynatrace monitoring as code, or visit dturl.net/Monaco. And 4 takeaways for us to wrap up. First of all, Teams enablement is really the key in DevOps. Automation, yes. Cloud, yes. Enablement, self-service, that's the most important thing. To extend our culture. Avoid manual configuration changes and start thinking GitOps. But automate where it makes sense, of course, where it delivers value. Don't automate just to say someone else, hey, I have automated everything. So what? And 4th, integrate GitOps with your existing automation workflows. For instance, Azure services, as you have seen. Don't reinvent something new just to automate more. Use what you use already, that you're familiar with. And I have started with a quote, and I'll end it with a quote. A quote from Catherine Lee. A quote that actually drives my motivation every day, because I don't want to let down. And she said, the last thing you want is to have your developer teams ask you for something and you don't have it for them. And it's a little bit sad every time I think about this. But fortunately, if you start to think about self-service, about GitOps, about automation, about enabling others easily without a complex and long onboarding to your application and processes, then you don't have problems like this. And this is what I have prepared for you today. Thank you very much. If you have questions, that's the time for this now. Or reach out to me on LinkedIn, on Twitter, or email, whatever you like. And if you want to get the trial of Dynatrace, just get in trial, or jump to our booth. And, of course, listening to questions. I see no. So hope that was clear. So thank you very much. That's everything.